with me just 1 second. Good, because there were some hiccups for this on Monday, so we'll make sure we record this session. Okay, so I'm going to do a quick review to make sure that we're all on the same page. Is that we are currently, and I'm going to share my screen just to make sure that we're looking at the same things, is that if we look at the actual certification block for this week, what we'll find is that we are ostensibly in the week of July 12th through the 16th. So we were finishing out the training that we were focused on,
Yep.
Which was the digital training, which I am actually going to talk about here in just a second. Oh, really? You're going to open that for me? Hold on 1 second. That's not what I wanted. And then I want to talk about how to use the exam questions, because I posted something in Basecamp to this effect, but I know that some people have had some questions, so I just want to make sure I'm being very clear. For the access to the AWS.training for the Cloud Practitioner certification, digital training, this training is comprised of about 11 modules plus the specific like final assessment. And so I just want to frame this up a little bit, because if you're a little, in a sense, if you're feeling a little behind, you're totally fine. There's really no such thing, because you've got, probably if we went another week and you were not close to being done, that might be a challenge. But we've got a little bit of flexibility here. So just to mention this, is that in this training, there are 11 modules, and hopefully, last week it was asked that you do like 8 modules. This week it was asked that you finish out the remaining modules and maybe do the final assessment. And then in addition to that, we were moving on to some like labs and other optional items that we could look at. So, right, because we were finishing up the digital training, and then we were also looking at potential like labs if you wanted some hands-on experience, if you were a kinesthetic person. They were just optional labs that were available if you needed them, right? And then we were starting to look at the practice exams. So let me just do a quick review on the Cloud Practitioner modules, and then I'm going to talk about the practice exams. And then if you have any we'll open the floor for questions at that point in time. So back to the modules. So the way that the exam is structured is it's broken down into 4 different areas. There's billing, there's technical pieces, there's core service pieces, and then I think security, if I remember correctly, is the other option. And so just know that these modules are going to cover varying pieces of this. Security and pricing, which are modules 6 and 8. The pricing, the billing one, is probably the smallest of the like the total exam, if you will. So, but what it does is it's going to go through compute in the cloud, basically how AWS does their particular like global infrastructure. In other words, where do you put your data? Where do you run services? Because some of the services operate at a regional level, some of them operate at a global level, and then there's other options for that, but those are really the main, and some of them operate on the edge. So those are really the 3 locations, is that you've got kind of in an availability zone inside of a region, you've got global, and then you've got edge locations, which you typically don't assign services to edge locations. You just turn them on, and Amazon manages all that for you. And then you then have some networking pieces, which basically just talks about how AWS, if you have to have a network card attached to your service, where does it put it? And it functions remarkably like our home networks. So I know it's more enterprise class, but in terms of like, you have like subnets, you've got some kind of connectivity to the internet, you typically have a translator of some type, you've got firewalls in place, which actually, oddly enough, we actually all have on our home networks. We just might not be managing them. So, and it also talks a little bit about global networking and how to connect to AWS. And then there's a section on storage, which is basically data, either data applications like databases or hard drives and like network storage. And then it talks about security, which, pretty much every configuration option inside of AWS has a security implication for the most part. And then module 7 talks about analytics, like monitoring and security, which mainly focuses on 3 services: CloudWatch, which is a metrics repository; CloudTrail, which tracks all the things that make API calls or software calls against your AWS account; and then Trusted Advisor, which is oddly enough not used by most people, but it is there because trusted advisor advises you when things go awry, they go weird in your account. And then pricing and support, which talks about the free tier, some of the like billing tools that are available to you. And then there's the migration innovation, which talks about, the different ways you can transfer data into AWS. Amazon has a cloud adoption framework they talk about as well. And then there's some more stuff here on what they perceive as the cloud journey, including the well-architected framework. And of course, Amazon's stated benefits of the AWS cloud. And then they talk a little bit about the exam for the module. So, and then there's the final assessment. So just so you're aware, most of the heavy lifting is done in the first 5 modules. That's where most of the densest information is. Everything else, it kind of flows downhill from there. It's a lot easier. It's a lot simpler. It's a little bit more conceptual. So those are the 11 modules plus the final assessment that we have for the cloud training. Has anyone run into any issues or any questions or curiosities about any of this? How's everybody doing with this whole thing?
It's pretty good. Pretty good. Yeah, I like the coffee shop analogy, so that's pretty.
I did have a couple of issues with some of the videos hanging while I was watching periodically. So I had to kind of keep restarting the page. I don't know if anybody else was having similar issues with them.
Nope.
But the content itself was, yeah, I also liked the coffee shop analogy, much easier than when I took this class a little over a year ago without the analogies, much more difficult to grasp.
Yeah, and that coffee shop analogy is actually pervaded into the classes above this level as well. So you'll see it
Nice.
show up.
Oh.
Yeah. If you take the new developing, the new system operations, or the new solutions architecture, I know it's in system operations, and I think they just put it into architecting. Developing is still pending, but they're starting to weave that in so that you can have the same kind of metaphor allegory as you go forward.
Right. I wonder if they do the inverse. If you're training for Starbucks, if they use AWS.
Right. Right. That'd be hilarious. Let's talk about advanced computing concepts and how they relate to your life as a barista.
Yeah.
Right. Yeah, exactly. That'd be hilarious. Good. The video hanging, the only thing I've ever seen the video hanging is if it wants you to relog back in. This login seems to have a short lifespan. So yeah. But
okay.
yeah.
Yep.
The other thing is that it doesn't seem to work very well outside of Chrome. So if you're using another browser, there seems to be all kind of weird behavior that happens.
Oh, no, definitely Chrome. But it could be the login time frame because I'm trying to catch it in between meetings. So it could just be the timing. So
yeah, I was just in this an hour ago, and I think you probably just saw me just log back in, right? So it does not retain the login state at all.
Yeah, I think it times out after 30 minutes. So
yeah.
Okay.
Like that. Yep.
Yeah. Okay. So there's that. So if you are like, hey, I've only got to module 6, or I'm at module, whatever, 8 or whatever, then fine. Just go ahead and finish out the rest of the modules. But just know it's an easier proposition from here. Would love for you, when you feel comfortable with the final assessment, post that out. Actually, post out your final assessment when you pass it. By the way, is there anybody who's done with all the modules?
Me.
Yeah, John. Anybody else?
Yeah.
No. Okay.
Well, what did you want us to post?
Just post out your score in the assessment, right? Where you felt challenged, right?
Oh, here in the chat or in the Basecamp.
Post it in Basecamp. Yeah.
Okay.
Yeah.
Yeah.
I don't know that I've taken this recently. Oh no, I definitely have. I just don't know.
Yeah, my only feedback about that is take your time, and it got me because of some stupid, not paying attention and not really reading the question correctly. So that's one of my advice.
Yep.
Take your time. Don't be like me.
Yeah, it does require us to put on our detail orientation glasses.
Yeah. Because of course I'm like, yeah, I know all of this, right? But then you get humbled every day. Let me just say that.
Yeah, that is a very true statement. Okay. Well, so John's going to open up the like Basecamp thread. As you finish your assessment, just post it in there.
Okay.
What I'm mainly interested in is just going to, usually we'll tell you sections that you might want to take a look at. We're mainly going to rely on the practice exam for that, but just, be aware, right? Just to create some momentum around it.
So just create a new message in the message board.
Yeah, just post a new
Okay, cool.
message. Does anyone, if no one has any other questions, I'm going to pivot over to the practice exams then. Okay. So the practice exams, this one is another one, by the way, that has that same login problem. I've probably literally been here 3 times a day, and it's just going to ask me to log back in. So give me just 1 second. So when we take the, hold on, let me get to the right one. Cloud Practitioner exams here. What I mainly want you to focus on, and I know this is a little bit of an eye chart, so I'm going to blow it up, is that I really want you to focus on the review mode exams, not necessarily the section mode exams, although you can do the section mode exams. What I'm interested in you doing is that you really only need about 2 or 3 of those that you're going to focus on. You're going to take these same 2 or 3, right? The idea is because these review mode exams allow you to check your progress, that's really what you're focused on. Now, you might not do one this week because you might be finishing up the cloud module, but definitely by next week, you definitely want to take one of the review mode exams, and you might not be able to dedicate like a piece of time to finish an entire set. And, I want you to do your best to kind of run through it until you can. What I'm looking for is that I'm looking for you to like start like practicing seeing the questions and understanding their breakdowns. So like, for example, in this first question, it's like, what's the minimum number of availability zones you should set up for an application load balancer to create a highly available architecture? Now, when you see those kinds of questions, and I'm going to go into this even deeper, but I'm going to repeat myself here, is that you want to get very specific about what the question is asking you, right? They want the minimum number of availability zones for an application load balancer for a highly available architecture. Those adjectives like cost-effective, highly available, resilient, redundant, fault tolerant, they're going to throw adjectives in there, and those are going to set the tone for the thing that you're looking for. Because quite frankly, if this was about costs, but we just run one availability zone, that was the thing we were most prioritizing. But here they're asking us to prioritize high availability, which best practice for AWS is to use 2. Now, when you get these questions, like I said, you're not going to necessarily have a big chunk of time to run through all of them at one time. You want to immediately check your answer, because what this will do is that John and his team will tell you, first of all, whether you're right or wrong, which is good to know, right? Because then you can make sure in your brain it's cemented. And then it'll explain exactly why this is the right answer. And then it will tell you why the other ones are wrong. It'll tell you one availability is wrong because if there's an outage, which could happen along the availability zone, then you need 2 to make it highly available. 3 and 4 is incorrect because they will provide you with fault tolerance, but you only really need 2. And so 3 and 4 is overkill, unless you've got business continuity rules that say 3 or 4, but they don't say that. They just say highly available. To meet highly available, according to the question, you just need 2. So the point to saying that is that, 1, I really just want you to be able to come in here and start running through questions. It starts building your mental stamina, starts teaching you how to think about the questions, starts teaching you to like look for those key words. But if you're distracted while you're taking this, and which I've done several times, like I've had the things where I'm like, well, I'll just sneak this in between like teaching classes. It's fun, I got 15 minutes, I'll just sneak it in. And but I'm actually not focused. I'm actually quasi distracted. You'll miss those keywords, and then you'll miss the question, and it won't be a real gauge of whether or not you're going to pass the test because you're not focusing. So just know, while you can sneak it in small chunks, just make sure you're not distracted internally. If you are, don't waste your time. Like if you're unsettled, need to take a break or whatever, then don't sneak in a question. But if you can really do this for 15 minutes, then sneak it in, right? And so the other thing is that John's going to give you, his team's going to give you the right answer, the wrong answers. And then if you consistently get load balancer questions wrong, well, then go take a look at the Amazon documentation. Well, that's about EC2, right? but application load balancers might be of interest, right? And maybe just take a quick gander at what an application load balancer is, right? Later on, John actually has cheat sheets by topic. So if there's a S3 or something, he actually has cheat sheets on his website for that. And just so you know, that was multiple single answer. This is multiple right answers, basically. And so for in this case, companies planning to adopt a hybrid cloud architecture, keyword hybrid, right? Which of the following can they use to assist them in estimating their costs? And so this is a 2, there's sometimes 3s. I don't think I've seen a 4 in a while, not in Cloud Practitioner. But in this case, they're like, what can we do in estimating our costs? Like in a sense, like forecasting to a certain degree, right? So I think a sales representative would be super helpful, but they're not an option. So let's go for pricing calculator because we can price out architectures. Tagging might be useful. Consolidated billing might be useful. Cost Explorer might be useful because Cost Explorer actually does not only existing costs, but does future costs. And so as you hear me verbalizing my reasoning. I actually know, well, I don't know what a sales representative would do. I mean, I know what they can do, right? But I know what cost allegation tags do, and I know what consolidated billing does, right? And if I hit check, what that does is it will then validate my guesses, right?
Wow.
Now, I thought Cost Explorer would be a great option, but it actually turns out that it's not. They're actually saying that a sales representative will be a good option, right? Let's find out why. So Amazon goes on and says, hey, we're utility computing, and that to estimate a bill, yes, absolutely, we can use a pricing calculator, right? But what's interesting is that it doesn't say why an AWS sales representative would actually be a good idea, right? So I might not necessarily agree with that answer, but he does go on to say, look, Cost Explorer is incorrect because it's only going to forecast based on your previous usage. So remember that the scenario says that the company is just planning to adopt a hybrid cloud architecture, which means they can't use Cost Explorer yet to forecast because they don't have any prior art. So then in my thinking, I was incorrect. I was sitting here thinking that maybe I could forecast some costs, but you can only do that based on prior usage. So Cost Explorer isn't an option. Tagging wouldn't work, but I already knew that because that just allows you to add dimensions to a report. And consolidated billing doesn't work because that just consolidates billing. That's not going to help me with estimation. So
yeah, I was on the fence about the Cost Explorer, right? Because it's saying planning, right? So if you're not in there yet, you can't really use Cost Explorer. But I've never really heard of the AWS sales representative in any of the modules. So
yeah,
or maybe I wasn't paying attention. Yep.
Well, and what they're saying here is that basically talk to your AWS rep and say, hey, we're about to do something. Can you help us? And they will, and they have other tools, right? But Cost Explorer is only good for existing workloads. It will forecast based on existing workloads, but you can't add non-existent items into Cost Explorer and have it extrapolate out. Now, probably, by the way, for some of you are sitting there going, wow, that was a lot of information that you seem to know about how this functions, right? So just know that that's what we're studying for, right? Is that we're studying so that you can also get to a similar level of information. So if some of you are like, man, Michael, you just lost me about halfway through that, don't worry. That's what we're doing these practice exams for, is so that you can get to that level of knowledge and that level of expertise. Okay, so that's what I would really want you to do, is I want you to use the review mode exams. And if you want to do section based, you can, but we're not going to touch the final test, which you can see on the lower left-hand side. You touch that for your assessment. We're not going to really touch that again. Now, for those of you who were able to get to the final test, because remember, this final test, right? If we look at it, if we look at the instructions, is basically a 65 multiple choice question that requires 90 minutes. So hopefully you've already done this assessment, because that was one of the first things asked of you. Has everybody done the final test? Everyone did it already?
Yep.
Okay, good. So ideally, whatever your number is, I'm hoping that everybody remembers that. I'm actually going to post something up into Basecamp for just a second. I'd love to know what your number is, because you got to remember, there's no, if you got a 5, a 3, a 38, a 75, doesn't matter. Your number doesn't matter. what matters is not the absolute number. What matters is the differential as we get towards the end. So we're looking for a rise. If you're not comfortable with that, you can just send it to Jana if you want to. She'll take it, right? Yeah. But
Just
just
compare
know,
how terribly Jana did and then laugh, point and laugh and be like, oh, at least I didn't do that bad.
yeah. Well, and hopefully, honestly, to say this is I hope you all actually did badly, because that means you don't know the material. And so this is what we're doing is we're trying to teach you the material. If you got a 95, then we should talk, because you should just go ahead and take the exam, honestly. Right. And if that happened, please, reach out to me or to anybody involved. And so we can talk, because you're probably ready to take the exam. Did anybody, by the way, get a 90 or 95?
No.
One day.
Google searches are your friend.
Yeah. Well, if you could Google search everything in 90 minutes, that in and of itself, Andy, is its own impressive skill.
Yeah, I was gonna say that'd be pretty impressive.
Yeah.
I got a 50. No, straight up.
Wow.
No
Nice.
Google
Pretty good.
searches.
Yeah. So that's great. That's a great place to start from. But I mean,
was just-
like I said, a 5 is also a great place to start from. So either
I was
one.
only trying to beat Rob's score.
Oh yeah. We're gonna hear a comment from Rob.
Well,
No, that's it.
No.
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 Denied.
Just a flat out no.
So we're not touching the final test again, but I'll post something up in Basecamp and you can post your score for your final test if you feel comfortable. Otherwise, honestly, you can send it to me privately. I would like to know, because I will or you can just keep track of it. But I want to know, because I want to know the differential as we get towards the end. So any questions about either the review mode, the section-based test, which we're just going to kind of ignore for the time being, or the final test, which we're not going to touch again till probably week 5. Any questions about any of that? Okay. Let's see. Did anyone have any questions about either serverless or containers? Because this actually came up on Monday's class. And I was curious if anyone had any questions about serverless or containers. Do you feel like you're good on those concepts?
No.
I think that topic is a good one, Michael.
Okay.
For everyone.
All right. So let's talk about it for a second, because I didn't record it on Monday. And so let's do just a quick walkthrough on containerization, and then I'll talk about serverless just to cement the concept. So let me pull this up. So this is actually from the official class running containers on EKS. It's just a small sample. It's just the official content. So it's not the entire, you get a little sampler, if you will, of the official AWS course. So the thing to mention here is that there's 3 ways to do application hosting. There's virtual machines, which we're all familiar with, right? Because that came out in 1999, and then VMware came out with their official product for the data center in 2002, I think it was, or 2001. And so we're familiar with virtual machine hosting because, right, that's what that's still 65%, 70% of the world's apps, not including mainframes. So virtual machines is one of the core ways we can host applications. Serverless is when you actually have somebody else manage the servers, and all you're doing is uploading code through usually an interface, and somebody else is managing everything else. Like you just kind of see that behind the scenes. In between serverless, which is very abstracted, and owning and running your own virtual machines is containers. So containers is an interesting concept because it's a mid-level abstraction where basically instead of virtualizing an entire virtual machine, including the operating system, like Windows on your laptop or a Linux box or whatever, instead of virtualizing an entire OS, you are just virtualizing a process. And you might say, well, what's the value in that? Well, look at this little ship here. So think about the shipping industry, because I think this is a good kind of metaphor to use, is that prior to, I want to say it was like the 1950s, when you wanted to ship tires versus bananas versus like ice cream, those were very different like packages, right? And so the container ships look like this, where it's like, well, this guy sent us a big old blob of tires. This person sent us a refrigeration section for the ice cream, and the bananas don't have a refrigeration section, but they have like a heat proof kind of box that they're in, right? And so, what ends up happening is that you've got this kind of jumbled way of actually managing how things are shipped. So if you extrapolate this out to the software industry, if you talk about Java versus .NET versus Ruby versus Python versus the various ways that we can actually package applications and share them with people or put them on servers, this is what it looks like for the most part. It's varied. There's nothing wrong with this, but we have to custom figure out every time we want to add a new language or add a new like runtime, we have to custom figure out how to handle the rectangle versus the square versus the other polygons that are there. Because we're like, we don't have tooling for that. How do we instrument that? How do we deploy it? And so what happened is that someone, who knows exactly where the source is, but Docker came out in 2013 and said, why don't we just use our existing technologies that we already have for these kind of things, and let's just standardize it. Same as we did for the shipping industry. The shipping industry said, you know what, we're going to make a rectangular metal box. It's all going to open the same way. We can attach refrigeration units to it if you want to. We can line it if you want to, but it's going to be a rectangular box. And as long as you have the infrastructure to deal with those rectangular shipping containers, whether it's a truck, a ship, right, or a train, we've got cranes that knows how to place these containers and deploy them onto ships and deploy them onto trains and deploy them onto trucks. We know how to do this because interfacing with the containers is the same. Now, don't get me wrong. Some of these containers probably weigh 20 tons. Some of the other containers, are full of like wool and they only weigh a couple 100 pounds, right? It's the same with our application.
Like a simpler analogy. I mean, right? We should be able to explain containerization and serverless, right? As an elevator speech. I mean, I'm kind of getting confused. If I didn't know anything about containerization, Docker, and serverless, right? Lambda. This already feels confusing to me. That's just my 2 cents.
Okay. Well, let me finish, John, and we'll see
Yep.
if you're confused at the end.
Yeah.
So what we're doing here is that we're basically taking our applications and we're standardizing the way that they're packaged. That's what containerization is. And so as long as we have the infrastructure to manage these containers, we can run these containers anywhere. We can ship them anywhere. We can use them anywhere. And so that's what Docker did. It's kind of like what Kleenex did for tissues, Docker did for containerization. Docker basically said, hey, you know what? If you have a Java app, if you package it this particular way and you use our Docker software, we can show you how to run this. Same way every time. If we take your .NET app and we package it this certain way, same way every time, if you give us that image or that package, we can actually run this on a ship or a boat or wherever you need it to run. As long as you have our software, our Docker software, we can run this for you. And so what ends up happening is that we go from bare metal servers that have libraries, operating systems, and apps on top of them to virtual machines, which is what we're used to, where with virtual machines, we're actually virtualizing not just the application, but also an operating system, to containers, where what we're doing is that we're actually shifting, right, from having to run guest operating systems, which is what we have here, to just running the applications that we need, including their associated libraries. And they're in these little jails, if you want to think about it, these little package jails called containers. And what this is this isn't virtual machine. This isn't like virtual machine virtualization. This is process virtualization. Imagine if you could take Word, stick it into a container, and that container can run on any system in the world. And you could have multiple versions of Word running side by side right on your Windows system because they're isolated from each other. And so that's all containers are. It's just process isolation. It's just process virtualization. That's what we're doing here. So with virtual machines, we basically created fake hardware and put an operating system in a package, and we ran virtual machines. With containers, we're taking a process, we're putting in its own isolated memory space, and that's how we're packaging it up. So if I take that container, like let's say it's app A, the one on the left here, and I'm running a Linux box, Nick's running a Linux box, and John's running a Linux box, and I give them the container, it will run exactly the same on their boxes as it does on mine, right? So just know that that's the beauty of containers, is that just like virtual machines before them, you can now just package up a process, share that process package with everybody, and it's guaranteed to run the exact same way that it does on my box, as long as we all have the software required to do so, which in this case is Docker, right? So if we continue to extrapolate that out, what this means is that we've now got this uniform way of packaging applications. And as long as Nick has the Docker software, like what they call the Docker runtime, and John has it, and Jacob has it, and Tom has it, if I give you access to my image, my application, you can download it and it will run on your system. Now, here's a word of caution. I just said that, but like if Tom's running Windows and I'm running Linux, my application, if it's built for Linux, is not going to run on Tom's Windows box. So just to be clear, since this is process isolation, it's not going to cross like CPU architectures or operating system boundaries. If my application is packaged for Windows, it's not going to run on Linux. If my application is packaged for Linux, it's not going to run on Windows, right? Because remember, this isn't a virtual machine. It's just a process. So when people talk about containers and they're like, man, I downloaded all these Docker containers last night and it had like Apache web server and it had, MS SQL database on it. All they're saying is that they downloaded a prepackaged process that they then ran on their system. But note that those containers are built for the operating system. So again, if I have Linux, I'm downloading containers for Linux, which is where most people are doing containerization. Windows containerization is just now kind of hitting its stride. So hopefully, John, that makes it a lot clearer. Is that clear? Because if it's not,
does, yes. Yep.
Okay.
Yep.
Okay, good. Now you might say, well, what's the benefits of packaging it this way? Well, you just heard portability. I can give my container image to Tom, Jacob, Janet, and as long as they all have the software, we're good. And how easy is it to get the software? The software is free. The containerization software is free and it is standardized. So it's really portable because it will run on Mac, it'll run on Linux, it'll run on Windows. So as long as my container is built for those CPU architectures and operating systems, we're good. The other thing that containers have enabled is that because microservice architecture has become more popular, I know, and don't get me wrong, there is some hype to microservices. Everybody's like, microservices is a little bit like Kubernetes, right? But there is some benefits to microservices. Microservices is where you basically take an application and you split it into a bunch of smaller apps, right? With some independence and some scalability between them. They work really well with containerization because now you can actually have processes just scale as services horizontally instead of like having this big monolithic application that has like basically a large code base that you now have to scale, and it's huge, like it's bigger, right? When I say huge, these processes are only about 20 megs to 50 megs in size. Back here, when we were looking at these virtual machines are at a minimum 2 to 4 gigs in size. Most of the time they're 10. So you imagine how much application efficiency you can get by running 100 containers on a single piece of hardware versus running what, 10 virtual machines on a single piece of hardware. And the whole reason for that, by the way, the reason this is considered attractive for people is that we're not duplicating this. See this guest operating system? We're not duplicating that. That is the bulk of the size of a virtual machine. We're not doing that. All we're doing is we're duplicating this and any libraries that we need. That's it. So containers are super tiny, super fast, super small, right? And so they lend themselves really well to horizontal scaling, which is what we were just looking at. The other benefits in terms of scalability, you can also get continuous deployment. Like for example, these container like images are what they call immutable. So if, Vinod and I are talking and he's like, look, I have a new network application that I need to release, right? And we already have version 1. When Vinod wants to release version 2, all we do is actually create a new container image that contains our new software. And that's now version 2 of our software. You can't go back and change version 1. It's immutable. Once you create a version of a container, you never go back and change it. You only move forward. So every time Vinod and I want to release a new version of our network app, we create a new version of our process and we just keep moving that code base forward, and that's it. And then we can just deploy it on whatever hardware we have that will support it. There's some more stuff here about microservices versus monoliths and other things that probably aren't super relevant, but just know that at its core, this evolution on the right-hand side is why containers are so attractive, because you're going from virtual machine isolation to process isolation. Now, Tracy was asking, can you pile the containers too high that they tumble and fall off? You know what? Has in real life is just in digital life. Just so you know, each physical host, for example, on this right-hand side, that's running a container can actually typically only handle about 100 containers. So you're not getting thousands on a single box. You're getting 100 at most, right? I mean, so even though these guys are tiny, and even though the system might actually have more resources to host more than 100 containers, 100 processes, most of the time you don't, right? There's actually some hard limits about running more than 100 containers on a virtual machine, on an operating system. Yeah. So the answer to that is yes. You can put too many containers on the system and cause the operating system to choke. Basically, is what will happen. Now, that being said, let's talk about serverless, because we just talked about containers, and containers is nothing more than process isolation. You could also think of, by the way, sometimes people say that containers are lightweight virtual machines. Just so you know, technically that's not accurate, but it's not a bad way to think about them. It's not a bad way to think about them, because they could be considered lightweight virtual machines but there's no operating system inside of them. So really, containers are process isolation. Virtual machine is basically virtual machine emulation. So let's talk about that last tier, which is serverless. So if we can host processes and we can host operating systems, then Michael, why is there this high tier called serverless? What does that actually mean, right? We're going to switch to a different slide for that one. So give me just 1 second. Any questions about any of that while I'm rolling over? No? So this is actually from developing on AWS, if any of you have taken that particular class. And it basically, the question that it answers is like, what is serverless computing, right? So traditionally, right, we run operating systems, and now, of course, we can run containers. But here's the funny, like for most of you that you don't know this, is that serverless, which means just running code, like not managing servers, letting somebody else manage your servers. You just give them the code and they just start your code, has actually been around longer than containers. So, and they came out kind of like pretty close to the same time. But traditionally what we would do is we would deploy a server, right? That's traditionally how we run applications. We deploy a server, we get a virtual machine, we deploy an app on top of the server, and that's the traditional virtual machine hosting that we were doing before. If we want to take that another level, we could deploy containers on top of that virtual machine, and we could get a lot of density, because we were just talking about containers and how they're process isolation. Well, serverless says, well, wait. We have cloud providers. I have other people now who can run servers for me. And by the way, people have been doing this since 2005, since a company called Heroku came out. What if I just give that company my applications and a few answers to a few questions, and they run the servers, but all I do is just run my applications? That's really what serverless is. Serverless is hidden servers. Anytime you hear serverless, you should think the servers are there. It's just they're hidden. Somebody else is taking care of them for you. So Amazon has a product called Lambda, and I'm just going to switch over to this really quick. And Lambda basically is an example of a serverless server. sorry, a serverless service in a sense. So what Lambda does is you just bring your own code. And by the way, it's packaged in a zip file. So this isn't packaged as a container. This isn't packaged as a virtual machine. This is packaged as a zip file. Because by the way, inside of a container, by the way, there's probably a zip file or a jar file, like some kind of like application file. So this is literally smaller than a container because it's literally just the application. That's it. A container actually has a little bit more to it. And then of course, a virtual machine has an operating system to it. So with a serverless setup, which by the way, Lambda is by far not the only serverless option. You know, Azure has serverless, Google has serverless. You can set up serverless on VMware, right? Microsoft has serverless. Everybody's got a serverless product. But all you do is you just give Amazon your zip file, or I think you can use a jar if you're using Java, right? But you just give them a zip file, a package of your code, including the libraries, and you tell it what you need from a performance standpoint. So like you see up here, it says select power value from 128 megs to 3 gigs. You basically say, look, my process needs 128 megs of memory to run. And then what it does is it'll give you a fraction of a processor and maybe like, you know, probably a gig network. And then what it will do is it will just run based on triggers that you specify. So for example, let's say that Rob and I are working on a brand new Pokemon app because Rob's a big fan of Pokemon. I just made all that up, by the way. I don't know if Rob's a fan of Pokemon or not. He might hate it, right? But let's say Rob and I, we love Pokemon because we're like the traditional Japanese otaku and we love it to death. So we're going to come out with a new version of the Pokemon app. But the first thing we want to do is we want to test our idea. So what we want to do is every time someone like uploads like a picture of a Pokemon to our website, we want to do some processing of that picture, get some metadata, identify the Pokemon that's inside of it. What we could do is that Rob and I could actually write a Python function that would basically scan the metadata, do some image recognition, and then maybe do some like tagging against the image. And so we could make it so that every time someone uploaded a Pokemon file to our S3 buckets out here on AWS, it would trigger this Lambda serverless function. Wait, Rob, were you going to say something?
I was going to say, then we're going to make money somehow, right? Off of this?
Are you kidding? It's Pokemon.
Microtransactions, dude.
Yeah, Pokemon's been making money since 1995. It's been running almost as long as Cops. I'm shocked. Even my like, you know, I generation like 9-year-olds are still loving Pokemon. It cracks me up. The show's been on the air for almost 25 years now. So yeah, we're gonna make money. So Rob, by the way, is getting the majority of the profits because he's doing all the writing. I'm just doing the infrastructure pieces. So what's gonna happen is that every time someone uploads a file to our like website, we're gonna trigger the Lambda function, and that's it. So to say this is that serverless is not for 24/7 running applications. So if Rob came back to me and said, Michael, we're making mad bank, we need to start a website, we're not going to stick that website into serverless. Why? Because serverless is not for 24/7 running applications. It's not. It's for events that get triggered, but it's not going to just sit there and listen for website requests. If we want to host a website, we got to go back to virtual machines or we got to go back to containers. So serverless, in this case, Lambda, is really for event triggered code. That's really what it's for. But don't let me fool you. You can get to 10,000 concurrent executions of your code in a second with Lambda because AWS handles all of the scaling and everything for you. You just give them the code, tell them how fast you want to go, and they take care of everything else as far as management of the systems.
Is Lambda the only serverless service in AWS?
Yes, it is pretty much
Okay.
the only serverless service. There are other services like Elastic Beanstalk where you just give code, but Elastic Beanstalk runs on virtual machines.
Okay.
Yeah, Lambda is the only one that's a serverless option. Okay, so in your heads, think Lambda is serverless, and this is just for event-driven code functions. So you just give it code, that's it. Containers can run 24/7, and all you're doing there is you're packaging the process in a special way so that it's uniform, but you can run that 24/7. And then virtual machines, you already know what to do with virtual machines, right? You stick an application on them, they're larger, but you get a lot of control with virtual machines and a lot of flexibility. So you can't knock them either, right? Questions about any of this around serverless, containers, maybe not virtual machines, but anything else? Okay. Let's see. Someone, Tracy was asking, is NoSQL similar? NoSQL is not, so think of NoSQL as being a schemaless, like consistency focused database type, if you will. What does that mean exactly? NoSQL databases tend to focus on horizontal scaling, so they focus on clustering. Whereas with a traditional relational database, you have one primary read and write, like one system of truth. You can actually have other read replicas for that system, but primarily there's one system that like kind of rules them are. I kind of like to think of it like, you know, our DBMSs tend to be a monarchy because there's one king or queen who rules the data set and is authoritative for the data set. With NoSQL databases, it tends to be a little bit more tribal. In other words, a little bit more like democratic, right? Where it's like you've got 10 boxes. They're all kind of authoritative for the data set, because if one of them fails, the other 9 will keep going, right? But in a traditional database, if the king or queen fails, your data is inconsistent, right?
Speaking of like NoSQL, would you say Dynamo is would you consider that serverless? Because you don't have to provision it, right?
I would say that Dynamo is serverless. So if, for those of you who are dealing with like the database section of the training, underneath the whole section around storage and databases, they are going to talk about DynamoDB, because DynamoDB is a highly managed NoSQL service, right? So Tracy, so DynamoDB would be the NoSQL analog. Just so you're aware, Amazon has like 10 database services, and there's 4 of them are NoSQL. So they've got MongoDB, they've got Cassandra, they've got something called Neo4j. They're under different names. It's like DocumentDB, Neptune, and Keystore, because Amazon has really horrible naming conventions for their stuff. So from my perspective. Okay. Tracy, I hope that answered your question. NoSQL is not super similar. It's a different way of managing data applications, but schemaless, horizontal scaling. Yeah. Okay. So it's 5:48. Floor is open. The intention here, by the way, is not to burn an hour. If we're done, we will end early. But if you have any questions at all, the floor is now open. So ask away. No? Okay. Reminder that you want to finish out your modules as soon as you can for Cloud Practitioner. And even if you're like, Michael, I don't know that I remember everything I saw. Move on. Get to the practice exams. The practice exams are going to force you to recall. You're going to find your gaps. You're going to fail. Then you're going to start succeeding. And then next thing you know, you might catch up with Andy, who got a 50. Next thing you know, you're at 75, right? And then next thing you know, you're at 95. So don't be afraid of failure. Just get in there, fail those practice exams horribly. And then as you keep doing that, you're going to start succeeding, right? So
and you said for the practice exams to kind of focus on like 1 or 2 of them and keep redoing the same 1 or 2 over and over.
Yeah, so preferably you would stick, for example, with like, let's say that you really love the number 3, so you're in the number 4, like just keep doing sets 3 and 4. If you want to do 1 and 2, that's fine. Doesn't matter to me, but pick 2, maybe 3 if you feel like you're going to do it fast, and just do those same 2 over and over again. If you're doing sets 1 and 2, don't add 3 in there or 4 in there or 5. Just stick with repeating sets 1 and 2 again and again and again. Once you feel like you have those masters, if you want to add a 3rd one, go right ahead. But I want you to expose to the same questions, because there's like 130 questions just in 2 of the tests. your brain is only going to hold on to so much. So don't move on past 130 questions until you get those mastered to like a 90, 95 percentile. So thank you for reminding me, Jenna.
Thank you.
Cool.
All right. Well, if no one has any burning questions, going once, going twice. All right. You know where to find me. I'm going to post into Basecamp and ask you about your assessment for your final test. So if you feel great for that, good. I'm going to put my email in there too. Email me if you don't have it. Otherwise, you're done. It's Wednesday. Keep going forward. And then we'll see you on Monday or Wednesday, depending on which group you're in. But hopefully we'll see you next Wednesday.
Thank you.
Thank
Take
you.
care.
All right, everyone. Take care.